Magandang araw sa inyo mga ka-learners! Welcome to another lesson. Let me ask you a question. When was the last time you felt an earthquake? Do you know what causes an earthquake? Are you familiar with areas in the Philippines and the world that are most likely to experience earthquakes? Would you like to know more about earthquakes so you can understand them a bit better? Then, this module is for you. In this module, we will learn all about earthquakes, from their types and causes, as well as their effects on both living and non-living things. After this module, you should be able to describe how an earthquake occurs, identify earthquake-prone areas in the Philippines and the rest of the world, describe how the occurrence of an earthquake is detected and how its strength is measured, explain how earthquakes affect people and the environment, and discuss safety measures to take before, during, and after an earthquake. Let's start by getting to know earthquakes a bit better. This lesson will be split into two parts, so make sure you stick around for part 2. That way, you won't miss out on any information. Here in part 1, we will learn a bit about plate tectonics. This will allow us to understand what causes earthquakes and why they are nearly impossible to predict. What causes earthquakes? Did you know that there are two types of earthquakes? Volcanic earthquakes are earthquakes caused by volcanic eruptions. The effects of volcanic earthquakes are usually felt only in areas around the erupting volcano. Tectonic earthquakes occur when there is a movement under the Earth's crust. They occur over a wider area than volcanic earthquakes. While volcanic earthquakes are pretty straightforward, tectonic quakes are always the ones that catch us by surprise. Tectonic earthquakes are better understood through the theory of plate tectonics, which tells us that the Earth's lithosphere, the rigid outer part of our planet consisting of the crust and the mantle, is made up of constantly moving plates. These plates, called tectonic plates, are like gigantic pieces of jigsaw puzzle that somehow fit together. Let's first look at the composition of the Earth. Did you know that the Earth is made up of 3 layers? There's the crust, the mantle, and the core. The crust is the outer layer of the Earth. It is a relatively thin layer made up of rocks. It's a layer of Earth that we see. On it, we can find mountains, hills, valleys, plains, and bodies of water. The crust is at its thickest in the continents, or the land part of the Earth, and at its thinnest in the oceans. The layer underneath the crust is the mantle. It is made out of rock materials, although part of the upper portion of the mantle is a layer of semi-liquid molten rock called magma. Yes, that magma that fuels volcanic eruptions. It flows slowly underneath the crust. The core is the innermost part of the Earth. It is made out of an outer layer of liquid iron and a solid inner layer of iron. For our purposes, we will focus on the crust and the uppermost solid mantle, which makes up the lithosphere. According to the plate tectonics theory, the lithosphere is made up of plates, each about 100 kilometers thick. These float upon a hot, soft rock layer called the asthenosphere. Think of the lithosphere as slabs of ice floating on water. The slabs of ice are the plates, while the water is the asthenosphere. There are 2 types of plates, the continental and oceanic plates. Continental plates make up the land part of the Earth. Oceanic plates hold the Earth's oceans. They are thinner yet denser than continental plates. Our planet is divided into 7 large plates, with several smaller ones scattered around them. These plates are moving constantly in varying directions relative to one another. The 7 major plates are the North American, South American, Eurasian, African, Indo-Australian, Antarctic, and the Pacific plates. These are called major plates because they are the largest in the world. Minor plates are smaller than major plates but still factor into plate tectonics theory. These include the Nazca, the Cocos, and the Philippine plates. Most plates are combinations of both oceanic and continental plates. However, the Pacific plate, the largest of them all, is almost entirely oceanic. These tectonic plates play an important role in understanding how earthquakes occur. Their movement is what drives earthquakes, both big and small. Have you ever wondered, though, why we don't feel these plates move beneath our feet? That's because they grow at the same rate as our fingernails. Tectonic plates move at a rate of 2 to 12 centimeters a year. That is a minuscule amount compared to how big these plates are. These movements, however, still cause drastic changes on the surface of the Earth. It's because of these movements that we have mountains and volcanoes. It's also why we have continents and islands. Why they move is still a mystery, but scientists believe that the reason for this is the high temperature in the inner core. It heats up the mantle, causing convection currents, rising and sinking movements in the magma. The magma rises and spreads out, then cools and sinks, dragging the plates attached to it. This constant motion of the plates puts stress on the lithosphere. Put too much stress on it, and it breaks or shifts. When that happens, a tremendous amount of energy is released in the form of an earthquake. Earthquakes often occur along plate boundaries. These are the areas where plates meet. There are 3 types of plate boundaries, depending on how plates move: divergent, convergent, and transform plate boundaries. Divergent boundaries, sometimes called spreading center, has plates moving away from each other. As this happens, magma rises from the mantle, creating mid-ocean ridges. These are vast mountain chains found in the ocean. This, in turn, leads to the creation of new crust on either side of the vent once that magma cools and hardens. That pull-apart motion creates tension in the plates, eventually breaking the crust and causing an earthquake. These tend to be weak and small because most rocks are weaker when pulled apart. Convergent boundaries or subduction zones happen when 2 plates move toward each other. When 2 plates collide, one of 3 things can happen depending on the types of plates that converge. When an oceanic plate collides with a continental plate, the oceanic plate goes down into the mantle and partially melts because of how hot magma is. That magma finds its way between and through the plates, comes out and forms a volcano arc or a chain of volcanoes. When an oceanic plate collides with another oceanic plate, it forms an island arc and a trench. An island arc is a curved chain of oceanic islands, while a trench is the deepest part of an ocean. When 2 continental plates collide, a mountain range is formed. This is why we have the Himalayas, the world-famous mountain range in India. It formed when the Indian plate collided with the Eurasian plate. The collision process in convergent boundaries leads to compression, pushing rocks together on the Earth's crust. This is why earthquakes are at their strongest in convergent boundaries, and the Philippines is on one. Do you know the Ring of Fire? It's a zone of frequent earthquakes and volcanic eruptions around the Pacific Ocean. Our country is in this zone. It stretches from the tip of South America, goes up the west side of South, Central, and North America, down to Japan, the Marianas Islands, Indonesia, Papua New Guinea, and Tonga, eventually ending on New Zealand. A transformed plate boundary is one where 2 plates slide past each other. Movement will not be smooth because of friction between the rocks of the 2 plates. This sometimes leads to the 2 plates getting stuck and essentially locked together. Because the convection currents are still dragging the plates, tension and pressure builds up at the transform boundary. When that becomes too much, the rocks in the plates break and get jerked apart, causing an earthquake. Let's look back at what we have learned so far from part 1 of our module on earthquakes. There are 2 kinds of earthquakes, volcanic and tectonic earthquakes. Tectonic earthquakes are brought about by the movement of Earth's plates. There are 3 kinds of plate boundaries: divergent, convergent, and transform boundaries. The Earth is made up of 3 layers: the crust, mantle, and core. The crust and the upper mantle make up the Earth's lithosphere. The lithosphere is made out of plates that move on the soft asthenosphere. The movements of the plates are caused by convection that occurs in the magma. In a divergent plate boundary, 2 plates move away from each other. This leads to the formation of mid-ocean ridges. In a convergent plate boundary, 2 plates collide with each other. When an oceanic plate collides with a continental plate, a volcano arc is formed. When 2 oceanic plates collide, an island arc is formed. When 2 continental plates collide, a mountain range is formed. The Ring of Fire is a zone of frequent earthquakes and volcanic eruptions. The Philippines is part of this ring. A transform plate boundary is one where 2 plates slide past each other. Earthquakes occur frequently on this type of boundary. That's it for part 1 of our lesson on types and causes of earthquakes. Sit tight for a short quiz to jog your memory, or log on to your online LMS account and look through a few of the activities there. We'll see you back here for the part 2, when we look at exact points where earthquakes happen and how to pinpoint their location.